Hey everyone, in this video we're going to be looking at exponent rules. So for each rule, we're going to start by defining it more formally with a lot of variables, break it down into simpler terms, and then follow that up with an example for us to wrap our head completely around that rule. Now, in order for the exponent rules to make more sense, we have to understand what an exponent is. An exponent is nothing more than the condensing of repeated multiplication. Right, so if I tell you 5 squared, we want to think of that as 5 times 5. 5 cubed, 5 times 5 times 5. So exponents just give us a way to condense multiplication. Okay, that's it. And if we can wrap our head around that idea, it's going to help us understand each of the following rules that we're going to go over. So the product of two powers, a times b to the m, times c times b to the n will give us a times c times b to the m plus n. What does that mean in simpler terms? If we're multiplying two expressions with the same variable, we add the exponents of that variable. So each of these expressions has the variable b, and what we're going to do is we're going to add the exponents of that variable. So m plus n, there we see the result in the final product. So looking at an example, we have 4x cubed times 6x squared. So we're going to multiply the coefficients. 4 times 6 gives us 24. And then x cubed times x squared, same variable. So we're going to add the exponents, and that's going to give us to the fifth. Now, let's take a second to understand a little bit more completely why that happens. Well, let's just look at the variable part of each of these. So x cubed is really x times x times x. If we were going to expand that, x squared, x times x. So expanded, x cubed gave us x times x times x. X squared gave us x times x. And if we're looking to combine these, well, there are 5 x's, right? We're multiplying x by itself 5 times, so that can be condensed to x to the fifth. Okay, so that's why we add the exponents when we're multiplying the same variable. Our next example, power to a power. So b to the m raised to the n is going to give us b to the m times n. So what does that mean? Well, if we raise a variable to an exponent to another exponent, we multiply the exponents together. Okay, so m times n. So in our example, we have x to the fourth, and that whole quantity is being squared. So 4 times 2 gives us x to the eighth. Now again, let's break this down a little bit further. If we're squaring something, that means we're multiplying something by itself. So this would be x to the fourth times x to the fourth. So we can use the rule that we just defined to the left, and we could even go further, right? X to the fourth would be x times x times x times x. And then x to the fourth, x times x times x times x. We have 8 x's here. So x is being multiplied by itself 8 times, which is why it simplifies to be x to the 8th. Okay, so I think looking at it in this way makes these rules a lot easier to understand. Now we have the power of a product. So if we have the quantity a times b, and we're raising it to the m power, that's going to be a to the m times b to the m. So essentially, we're going to distribute the exponent to each variable in the expression. Okay, so in our example, we have 3xy squared, all raised to the second power. Okay, so we want to think of this as 3 squared, and then x squared, and then y squared squared. Okay, so each term of our expression has been raised to the second power, so that's going to give us 9 x squared y to the fourth. And again, I can write this out, right? If I'm squaring something, that's 3x squared y squared. 3x rather. There's no squared on the x. And then that's times 3x y squared. Right, so if we're multiplying, 3 times 3 is 9, x times x, add the exponents, 1 plus 1 is 2, and then y squared times y squared, 2 plus 2 is 4. Okay, so we see all the rules kind of build off one another. Now the power of a quotient, so if we have a divided by b, that whole quantity raised to the m power, that simplifies to be a to the m over b to the m. So again, we distribute that exponent to each part of our expression. So in our example, we have x squared over y raised to the 5th. So that's going to be x squared to the 5th over y to the 5th, which fully simplified, we have x squared to the 5th, right? So a power to a power, we multiply the exponents. So x to the 10th over y to the 5th. And again, we can expand it out to make sense of it, but I think we should get the idea for these. Our next example, quotient of two powers. So a times b raised to the m power over c times b to the n power is going to give us a times b to the m minus n over c. Now, we should make note here that we are assuming that m is greater than n. Okay, so what does this mean? Well, if we're dividing two expressions where they have the same variable, we're going to subtract their exponents. And it's going to be the exponent in the numerator minus the exponent in the denominator. Okay, so for example, we have 4x to the 7th divided by 10x to the 5th. So first, we'll simplify the coefficients. So 4 over 10 simplifies to be 2 over 5. And then we have x to the 7 minus 5, right? Exponent in the numerator minus the exponent in the denominator, which is going to give us 2x squared over 5. So why does this happen? Why do we wind up subtracting the exponents? So again, let's just look at the variable terms. So x to the 7th, x times x times x times x times x times x, one more, over x times x times x times x times x. Okay, well, if we understand that anything divided by itself simplifies to be 1, we have a lot of simplification we can do. These would simplify, 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 and we're left with just 2 x's multiplied by one another, which would simplify to be x squared, right? So by subtracting the exponents, we're looking for how many sets of that variable would simplify because of the division. Now, what happens if we got a negative number in the numerator? We typically don't like to leave our expressions with a negative exponent. So that leads us into our next rule. So negative exponents, if I have b raised to the negative m power, that's equal to 1 over b to the m. So what's a good way to think of this? This is essentially the reciprocal rule, right? If something's raised to a negative exponent, we want to reciprocate that expression. Okay, and what if we have a negative exponent in the denominator? Well, we can reciprocate it so it winds up in the numerator with a positive exponent. So for example, we have 5x to the negative 3rd. Now notice, only the x is being raised to the negative exponent. This is a common mistake that students make. Only this part of the expression has a negative exponent. So that means we're going to have 5 over x to the negative 3rd is going to move to the denominator as x to the positive 3rd. Okay, and we can show this with a similar argument here, right? If we have negative value in the numerator, that means there was more terms in the denominator than there was in the numerator, right? So those terms would stay in the denominator instead as positive exponents, okay? And our last rule is the 0 exponent. So b raised to the 0 power is equal to 1 as long as b is not 0. Okay, so our example, 2x raised to the 0 is going to be equal to 1. And there's a couple of different ways that we can figure this out, okay, why it wouldn't be 0. One of the ways that I like, let's think of it this way. So if I have 2 to the negative first, 2 to the 0, 2 to the first, right? So 3 kind of consecutive powers of 2. Well, negative exponents say that 2 to the negative first is 1/2, and 2 to the first is 2. Put some commas in here. Okay, so this is one way that we can understand why it wouldn't be equal to 0, right? Because 0 doesn't fall in between 1/2 and 2. Okay, it's going to be 1. So we have 1/2, 1, 2. And we can also take a multiplication argument here, right? How do I get from 2 to the negative first to 2 to the 0? Well, if I multiply something with the same variable, in this case it's 2, the same base, I add their exponents, right? So if I have 2 to the negative first times 2 to the positive first, that would be 2 to the 0. Well, 2 to the negative first is 1/2. 2 is 2. So 1/2 times 2 is 1. Okay, so that's another argument for why raising something to the 0 power is going to be 1. Key idea here though, b can't be 0. If it is, that's something we refer to as an indeterminate form. That's a little bit beyond the scope of this class, but if you're interested, I encourage you to read up on that. It's quite interesting. So now let's look at a few example problems. Hey, all answers should contain only positive exponents. So that just means if we get a negative exponent, we have to take it a step further. So 10x cubed times 3x to the 5th. So we're going to start by multiplying the coefficients. So we get 30. X cubed times x to the 5th, same variable. We're going to add the exponents. So x to the 8th. Right? Imagine expanding it. This would give us 3x's, 5x's. In total, we'd have 8x's. 4x to the 5th, quantity squared. So that's going to be 4 squared, x to the 5th squared. So that's going to be 16x to the, so we have power to a power. We multiply the exponents, x to the 10th. Again, this would be x to the 5th times x to the 5th, right? 5x's times 5x's, 10x's, x to the 10th. 2y cubed over x squared raised to the 3rd. So that's going to be 2 cubed, y cubed cubed, it's a weird 3, over x squared cubed. Now simplifying, we'd have 8. Let me rewrite that a little bit nicer. We'd have 8 y to the 9th over x to the 6th, right? Power to a power, we multiply. X to the 10th over x cubed, so that would be x to the 10 minus 3, which is going to be x to the 7. Again, 10x's in the numerator, 3x's in the denominator. 3 sets of x's would simplify. We'd be left with 7x's. Now, same problem, but reciprocated. So x cubed over x to the 10th. So that's going to be x to the 3 minus 10, which is x to the negative 7, which, using our negative exponent rule, becomes 1 over x to the 7th. And this is a good example to point out 3x's in the numerator, 10x's in the denominator, 3 sets would cross out, and the 7x's would be in the denominator, not in the numerator. X to the 4th times y squared over xy cubed, that whole quantity raised to the 2nd power. So we have two choices here. We could either square everything and then simplify, or we could simplify and then square everything. So let's start by simplifying. So inside the parentheses, x to the 4th over x would give us x cubed, 4 minus 1, and then y squared divided by y cubed would be y to the negative 1st squared. So we're going to square each term in here, so that's going to be x to the 6th, y to the negative 2nd, which is x to the 6th over y squared. Notice, only the y variable gets moved to the denominator because that's the only one that's being raised to a negative exponent. All right, 3 more to go. X over y to the negative second. So my personal opinion here is to first deal with the negative exponent. So really treat this as x over y to the negative first, and then square it. So essentially rewrite the problem. Now this negative exponent for a fraction is going to reciprocate both the numerator and the denominator. So that's going to give us y over x quantity squared. Right, x to the negative first would be 1 over x. Y to the negative first in the denominator becomes positive y in the numerator. And now we square each term, so y squared over x squared. 5x cubed to the 0 power. Well, that's nice and straightforward. That's just 1. And then we have the quantity 5x cubed raised to the negative third power. So in this case, the whole parentheses is being raised to the negative exponent. So we'll have 1 over 5x cubed cubed. Right? We reciprocated it, becomes a positive exponent. Then we're going to distribute that. So 5 cubed and then x cubed cubed. So we'll have 1 over 125 x to the 9th.